Hi everyone, good day and welcome to another class. In this class, I'm going to take you through what we called Friedman's ANOVA. Friedman's ANOVA. So why do we conduct this ANOVA or one-way ANOVA? Why is it important? Okay, so this is normally conducted when you assume that the same subject, the same set of data is being repeated three or more times. Three or more times. So here, I'm going to assume that I have 25 workers who, within a certain week, they did morning shift, afternoon shift, and evening shifts. I just want to know whether there are some significant differences between them. The same workers, the same people. Are there significant differences between them? I just want to know. I'm not sure. Okay, so two things. If I look at the assumptions of the data set and the data set tend to be parametric, the best method to use is called repeated measured test, t-test. But in this context, or in a context where you know that you don't have that, then you have to choose the opposite, which is the Friedman's ANOVA. Okay, so here I'm going to see, just going to put my data set. And my null hypothesis is that I assume that there's no significance between whatever hours that they work in terms of their productivity. And then the alternative hypothesis is that there is a difference between their productivity. So let me go straight to the point and then just put it here. So I have my 25, I'm going to change. So these are the workers. And this is morning shift, afternoon shift, and then evening shift. With respect to these three, what is happening is that these are not strengths, but they're actually numerical values. So I need to change them, the morning shift in terms of the hours. Okay. And then in terms of the scale, I have to change as well. In terms of the measurement or the measure. Apart from the first one, the rest are all scale, measured scale in terms of interval or ratio. So I have my data set. So what next? So normally if I check this data set and it turned out to be parametric, then the best thing for me to do is to come to analyze, go to general linear model, and then here, as you choose, repeated measure sample test. But in this context, it seems I don't have that function. But if you have it, you can run it. Because I don't have this function, then I'd rather try and run non-parametric. I'm just assuming that this data set is non-parametric. And because I'm assuming this data set is non-parametric, I will just pick the related samples and then go to the fields, then move all the three shifts, and then change the settings, change the test by clicking on Customize Test, and then I will choose Friedman's two-way ANOVA, as you can see here. And after this, the rest, they are not important. You can keep them or you can change them based on what you want to see. So you click on, okay, so the same thing, same workers, repeated. You click run, and let's see the results that will come out. Here, I'm going to just focus on the outputs. which is more of the hypothesis test summary. The other things can be discussed another time, but today I'm just going to focus on this and then let you know whether there is a significant difference between them or not. So, okay, so based on the null hypothesis says that the distribution of morning shift, afternoon shift, and evening shift are the same. In other words, there's no difference, okay, in terms of the workers' productivity, these 25 workers. That's the null hypothesis. So the alternative hypothesis says that there is a difference, just as I stated it from the Excel sheet or in the Excel sheet. Okay, good. So what next? Now let's look at the significance level here, or the p-value. The p-value is showing that we have 0.110, which is greater than 0.05 or 0.001. And because it's greater, the p-value is greater than the significance level 0.005 or 0.001, we are going to retain the null hypothesis. And to retain the null hypothesis means there's no difference. So it's just affirming or confirming the null hypothesis that there's no difference between the three shifts. Okay, so that's one way of doing this. The same if you want to use another approach, but you get the same results. You go to non-parametric test, you use the legacy dialogues if you want to use, and then you pick the K-related samples. K-related samples. So here, you select all the shifts, and then you choose the kind of test that you want to run. So which is Friedman. And if you want to add any statistics, that's up to you. But here we don't need the statistics for now. Let's focus on the Friedman test. Now let's get the test results. So the test results is also showing the same thing, 0.110, as we got it from the other approach. It should give you the same answer, asymptotic significance. So the p-value here is also greater than 0.05. And therefore, what is going to happen is that we are going to retain the null hypothesis and then reject the alternative hypothesis, which we will conclude by saying that there is no significant differences between these workers, the shift that they take part in terms of their productivity. There's no difference. They turn out to give out the same level of output. Thank you very much, and I wish you all the best. See you in my next class. Bye.